Okay, so now that we have our project set up, they include folders, link files, and libraries, as well as our dynamic link locations have been established with our project. Let's go ahead and set up our example application. And what we will do is we will start adding a node in, kind of like a Sinbad node or something. And then from there, we will start adding a plane, a light, talk about lights and different kinds of lights that we have here, and then move to setting up cameras and working with shadows in Ogre 3D. So the first thing that we'll have to do here is to include our Ogre \example application header. This will give us access to functionalities from base application that then we can create a class and inherit. So just like what we have been doing so far, I'm going to create a class, and I'm going to call it my application. And then I'm going to make this inherit as a public child class from example application. Then within this class, I will create some public methods. And the first public method that I'm going to create is going to be my create scene. For now, let's leave it empty. And also, to make my life a little bit easier, I'm just going to use the namespace of Ogre. Now, remember, in using functions, methods, and attributes for our class, if we want to create or access certain things, for example, create a plane, create a mesh, scene nodes, and all those sorts of things in our project, we will actually have to use the namespace resolution for our Ogre project, and we will say using name Ogre : and then whatever properties you want to use. If we use this Ogre namespace, then we don't have to use the namespace resolution Ogre : So next, what we are going to do is going to and creating our int main function, and then return 0, and instantiate my application class and call it my game, and then set my game to run, or rather to go. So this is effectively the base application. I'm creating a class, then I'm instantiating a class in my project, and then I use that class.go method to run the game. So let's compile and make sure that everything goes well. And my build was successful. Now, at this point, if you get an error, take a look at what the errors are. If the error is pointing to some file.h is not being recognized, go and in your project properties, in the additional include library, include folders, make sure that you included the folders for Ogre include, Ogre overlay include, and boost include libraries. If you're getting any link problem, go into your link, or rather a link error, then go into your link project properties, and in the link input libraries, make sure that the link libraries are boost and your debug version of the libraries for your Ogre. And also make sure that the files that you're linking, Ogre main _d, Ogre overlay _d, and OIS _d .lib are spelled properly. And if you're getting a DLL error at runtime when you run the application, just like now, if you get a DLL error, that means that you're in the input, rather in the debugging section of your project properties, the folder for the binaries of Ogre is not spelled or included properly or added properly. So make sure that you do that. Now, I want to make sure that I'm not full screen and I'm using x3d9. And if you run this project, you should see an empty scene and a blank scene kind of like this, because the base application does not really have any objects, lights, or anything in it. So we won't be able to necessarily see anything. So we're going to close this run of our application. And now let's go ahead and create a plane. Okay, before I go ahead and talk about creating a plane, let's see how a plane is represented in Ogre 3D. If you remember from your basic mathematics, a plane is effectively in 3D. So if I have a 3D space, let's draw a 3D space basically with X, Y, and Z axes. A plane in 3D can be represented by one 3D vector or one 3D representation, and that is its normal. So for example, if I'm looking at the plane that describes the X and Z plane, then the only thing that I actually do need to be able to be able to represent every point on this plane is a normal, is a vector that is effectively perpendicular to the surface of this plane. So if this is my plane that I'm representing, the only thing that I need to know to be able to represent this plane is a vector that is completely 90 degrees on the surface of this plane, because then I can represent every single point on the plane. If you're looking at, let's say, drawing a plane that goes kind of like this, so a plane that goes kind of like this into this space, then again, the only thing that you do need to have is a three-dimensional object, three-dimensional entity that is perpendicular to this surface. And from there, you will be able to represent all of its representations. Actually, I do need another object to represent also a point in one of the points on this plane as well, because vectors do not have a location representation. So for example, this vector v sub 1 that's right there is exactly the same as the vector v sub 2 if their sides are the same, if they're both pointing to the same direction. So vectors only represent directional, or rather orientational information. So in order to also represent this plane, so I need to have a point and I need to have a vector, right? So for example, for the plane of xz, I need to have a vector vxz here, and then I need to also have a point on it. Any point would do. All right, based on this representation of the plane, so this is one representation of the plane. Now, another representation of a plane, let's talk about this with a green plane. So if I wanted to represent another plane, I also can, let's say that this time I want to represent a plane like this. All these representations are valid. What I can do is I can represent this plane with 3 points as well. So P sub 1, P sub 2, and P sub 3. So if I have 3 points in the space, I can also represent a plane that passes through these 3 points, basically. So all these representations are supported by Ogre. And I'll talk about this, and then we'll set up and discuss these representations in code as well. So Ogre allows us to define a plane in all these representations. Now, one way, so the first representation we talked about, so if I wanted to represent a plane in 3D, I need to be able to fulfill its algebraic formulation in 3D, which would be something like ax times by plus by plus cz plus d equals 0. This is an equation for a plane. So this represents a plane equation, a parametric representation of a plane. So I can represent it with these 4 coefficients. Now in Ogre, you could represent that and use it with the code constructor for a plane that takes in 4 real variables, A, B, C, and D. That's one way to represent the plane. Another way to represent the plane, as I mentioned, is to represent it with the vector and then offset along that vector. So you could represent it with something like, so you can represent it with this 3D formulation if x, y, and z are actually your x and y and z axes. Then you can represent it with a vector, a, b, c, times your unit vectors of x, y, and z, plus the variable. So Ogre allows you to also represent your plane by passing into it a vector 3 and the offsets. We call these last parameter, your offset. Also, as I mentioned earlier, you can represent your plane with a 3-dimensional vector and a point in 3D. So that would basically represent, again, this 3-dimensional space plus a point that pinpoints your normal vector. And so we call these actually normals. So Ogre also has an overloaded constructor for a plane that takes in a vector 3 for your normal and another vector 3 for your point. So all these constructions are valid and supported by Ogre 3D to create a plane. Now, we're going to go in here and start in our Ogre code to build a plane, a flat plane on our 3-dimensional space, and use that to be able to create a mesh out of. All right, now that we talked about how we can define a plane, let's go ahead in our Ogre application in the create scene method and create a plane. So as I discussed, we have various options to define a plane, and Ogre has several different kinds of constructors that allows us to create planes in 3D. So we're going to use the constructor that utilizes a vector and an offset along that vector to place our 3-dimensional plane. So since we already have the namespace Ogre, we will have access to the plane class. And from there, I'm going to create a ground plane. And it's going to use a vector 3 unit y, which basically will create a vector 3 with 0, 1, 0. That's basically unit vector that points towards the unit y direction. And I'm going to use a constant value of -10 for this plane. This is going to create my ground plane. Next, what I'm going to do is I'm going to use the Ogre Mesh Manager to create a plane off of this particular ground plane object that I created. The syntax for my ground, or rather my mesh manager that utilizes this plane to create a plane, is effectively going to take the plane object that I defined, and I'm going to give it a unique ID. And then I'm going to pass to it a bunch of parameters. And this is how it's going to look like. Mesh manager get singleton create plane. Then the parameters that I have, and we're going to go over this list quickly. The first parameter is going to be a name. That is the unique identifier for this particular object that I'm going to create. Then I'm going to pass to it a plane reference, which is going to be the reference to the plane that I already created above as ground plane. Then I'm going to pass to it width and height values in terms of how many units it's going to be because it's going to be a rectangular object, so it's going to be number of units in the y and number of units in the x directions. Then I'm going to specify segment x and segment y, or rather x segments and y segments, how many segments I want on each of those directions to have. So after we specify the number of segments x and y, then the next parameter, which is a Boolean, it specifies whether or not we want Ogre to calculate the normal to our plane. So the normal, as I said, is basically a vector that is perpendicular to the plane. The next three parameters that we will utilize are going to be our texturing parameters, specifying our texture coordinates, the number of items that we would like to specify our rendering engine to map our textures. And I'll talk about this shortly in a couple of seconds. So let's go ahead and specify the parameters of our plane. So as I said, the first parameter is going to be the ID. So I'm going to call it plane underscore 01. Then the next parameter is going to be my group name. This is going to be from resource, group manager, default group name. Next, I'm going to use my group plane or ground plane. Size of this plane, 100 along x and y axis. Number of segments along x and y, I'm going to use 20. I will set the default to be calculated. My texturing parameters. And the vector3 unit z would specify that the up direction for my texture is going to be the z-axis. And this should specify my plane, except that, misspell. Okay, yeah, I had misspelled my ground plane, so that was the problem. So this specifies my plane. Let's go and talk about how this plane would look like. So as we've discussed, in order for us to be able to render a plane, we need to be able to represent it in 3D for our application. So with the specifications of the plane that I have utilized, my plane basically goes in, and so in this particular application, I used the vector representation and the offset representation to create my plane. So that creates my plane. Then in the next phase, I used my scene manager, or rather mesh manager, to utilize this plane to build an actual mesh from this plane. Now, the plane representation with just a vector and the offset will just be very abstract. It wouldn't have any specific manifestation into the real world. So in order for me to be able to represent it, I actually create a plane, or rather a mesh off of it. In 3D, basically your meshes are represented by vertices. So I'm going to create a polygon that would go through this plane. Now, these vertices are going to be what my 3D system, real-time system, would realize and would be able to draw. But the plane that I created, let's hypothetically say that theoretically that plane was something like this, right? So I need to be able to represent its points, its vertices. And from the abstraction, that basically is a normal vector and an offset that specifies how far off from the origin this plane would be represented. So in order to create that representation, I basically utilized my mesh manager, and I said, hey, go ahead and create a plane, and I want this plane to be 1,500 by 1,500, and then to have 20 segments in each direction, x segments and y segments. So from that specification, my mesh manager will basically create vertices and split this mesh into these many vertices, 20 by 20, or rather 400 vertices. So these vertices are going to be then represented. And then the texturing parameters basically specify how far in or how I would like these texture to be applied when I apply a material to this mesh. So then now when you look at each of these segments, then basically your textures go along the U and V axis, which is going to be from 0, 0 to 0, 1, then 1, 1, then 1, 0. So these will be your texture mappings. And so the parameters that we specified in terms of our texture coordinates will effectively utilize the texture parameters on the surface of this two-dimensional mesh, or rather 3D static mesh that is basically a 2D plane, and allow our real-time shading mechanism to go ahead and associate the texture mappings on the surface when a material is applied to it. So then again, going over our plane creation, the parameters that we used for our mesh manager create plane method was the ID of the plane, or the name of the plane. Then we used the group manager, the name of the resource manager that would create this item. We passed to it the plane that we created, and the size of the plane, height and width, number of segments that we want this plane to have along the x direction and the y direction. Then the Boolean that sets true as if we want the normals that are created to be perpendicular to the plane. Then we set the number of texture coordinate sets that we want to use for our plane. Here we set it at 1. The next two values are the tiling along the U and the V texture coordinates, effectively saying how many repetitions of our textures we want to have. And finally, the up vector direction of the plane texture coordinate. So we use the unit Z, which is pointing towards the camera, as the up vector of our plane. And so this effectively will go ahead, will create the plane mesh based off of the plane representation that we created for our object. All right, fantastic. Now we have our mesh plane created for us. And so if you remember from this point on, what we would basically do is create an entity and then attach that entity as an object that we are going to use. Previously, we used, for example, for our meshes, we used Ninja entity and Sinbad entity and whatnot, and then we attached that entity as an object to the child of our scene node. So we need to do these two steps. So the first step is to basically go ahead and create our entity. So I'm going to create an entity pointer, and I'm going to call it plane ent. And so it would be from mScene manager create entity method. And the create entity method will take an ID. So plane ent underscore 01, and the name of the plane, or rather the name of the mesh, which in this case is going to be plane underscore 01. So now our entity is created. So then let's actually do a little commenting here. So here, create an abstract plane, create a plane mesh from the abstract plane, create a plane entity. And then create a scene node that would be the child of a root, and then attach the object to it. I'm going to just be lazy here and just create the scene node without directly, without creating an actually object of the scene node. So mScene manager get root scene node and then create child scene node attach object, and then the object that I'm going to attach is going to be my plain int. So in here, I created a child scene node for the plain and attached it. Now this plane would not have any material applied to it, so if we render it, we won't be able to see anything. So what we're going to do is we're going to add a material, or rather set the material of our plane entity. So plain int set material name, and then the material name that I'm going to use is going to be coming from the example beach stones materials. Okay, yeah, I misspelled the example. It should be examples beach stones. And so this should compile. So we're going to just compile this code and see how it looks like. And now let's run. All right, we're not seeing anything. I think let's debug this. Actually, I know why we shouldn't be seeing anything. It's because we don't have a light in the scene. So let's go ahead and create a light in the scene and see if we can see our mesh, or rather our plane with the materials applied to it. If we couldn't see it, then we'll have to go and make sure that the location of the beach stones that we are using is correct. So let's try that. Let's first add a light. In the next video, I'm going to talk more in details about the lights, but for now, let's just go ahead and just create a light and plop it in the scene and see if we see anything here. So first, I'm going to create a scene node. Scene node pointer for my light, and scene manager, create scene node. I'm going to call it node_01. Then add it as a child of my root. Yeah, it takes the object. Next, I'm going to create a light. Set this light type to be light lt_point. Then set the light position to be 0, 20, so it's going to be 20 units upwards, and otherwise at the origin. Then we're going to set its diffuse color to be white. So it would be 1.0, 1.0, then we're going to create a light entity. Or actually, let's just spell create light correctly. And then, so we set the light up and its position and its value. Now let's compile and see what happens. All right, so now as you see here, we have our material applied to the plane, and we place the light. And so the reason that we couldn't see the scene was practically because there was no light in the scene. So we just added the light. Now I'm going to close up this video. It's kind of, I think, getting to about half hour video. I'm going to close this up now, and next we will go in and then we will create a light, and we're going to attach that light into our scene node for the light, and then we're going to also create a sphere object that would be placed at the location where the light is, so that we would be able to actually see it, see the light. Right now, as you see, lights don't have physical representations in the scene, kind of like planes. So what we did, we created a mesh based off of our plane. Now we're going to create a sphere for physical representation of our light, and then we'll place those two to be attached to each other as scene nodes. And then we're going to talk about different kinds of lights, their parameters, and how Ogre 3D utilizes these to render objects and create interactions between lights and materials.